Hi everyone. So let's start a little bit with the science fiction. Yeah, I think everyone knows the movie Iron Man. For those, I hope this is not new information. So I think it was 2008 when Tony Stark introduced his R reactor, right? He was actually forced to create one because he wanted to sustain his life, right? The first generation, I would say all generation been based on palladium, which in first generation has been actually contaminating his bloodstream. So he had to put out the core and replace it quite often. But he kept digging. And in the third generation, he achieved a state when the reactor itself was way more sustainable. And moreover, it was producing enough energy to power not only his suits, but all his cool gadgets he had. Okay, but right now let's go back to our planet. To our planet Earth, the only known planet that is able to sustain the life form we know today. The only one planet in the universe we know that is able for millions of years recover itself. So let's explore together the process that is essential for us and how can we contribute to this planet process. So let's introduce the Green Masterplan, Java 21 and 22 and beyond. My name is Miroslav Wengner. I am involved in Java community ecosystem actually for a couple of years. And recently I have published the book Practical Design Pattern for the Java developers, which actually the main motivation of this book was actually contribute to this green effort, how to produce the sustainable software. And I'm working for an amazing company called Open Values, which is already making a lot of thoughts about how to create from the small software to the big scale software for the companies. So before we start, let's add the safe harbor so that some information that I may publish may offend someone. But I hope not, because as we all want to maintain the life form on our planet, which is essential for us, I think we all agree with them and we accept them or trying to research them. So here's my agenda. So I first take you on the trip to the energy, how it's consumed. And then we go from the major release 21 to the 22 and make some conclusion at the end. So since the time we have used the stone tools, we as the human race have done the dramatic process, right? These stone tools been actually used to sustain the life, right? And over the years, we developed some more complex mechanical one. And what was funny is that in that time, we've been really precisely concentrating how much material we use to produce them. Yeah. And with coming of electricity, actually the Industrial Revolution, we produce more advanced tools, right? They've been able to sustain way more lives. And we got these cool gadgets like electric cars, solar panels, the heat pumps that theoretically should be green, right? And they all kind of have the similar denominator if you take a look. And what is it? Oh, it's a software. And with coming the cloud services, which are part of the Industrial Revolution, we just used to deploy the software there into the cloud. And this is the data center from the Google in Oregon. It looks very small building compared to the very long field of solar panels that is surrounded by. Yeah. So almost look green. So yes, but we started to taking the energy as very granted. Like we just deploy to the cloud and we don't care what is happening there. Just as a path, this is a kind of part of our pipeline, right? So, and here is the impact from Industrial Revolution. Actually, since we start measuring in Hawaii and 2060 around, I think since that moment, the annual temperature, surface temperature actually risen up 1.5 degrees Celsius, which seems not much, but there are some parts of the Earth, they become colder, some very hotter, and we are experiencing it and the impact that not only by the warming, but also the sea level is coming up, which I think in the very near future may some cities on the seaside face some difficulties. Maybe they need to build higher barriers. So yeah, the past is knocking. And these data center prediction, they made a prediction, it's very near future, like 2025. It's in few months, right? So all these data center will consume 20% of all energy we do have. That's very cool. And they produce only just a 5.5% of the emissions, carbon dioxide. Well, yeah, I think we should start thinking about to take in energy of our software into the equation. Yes, because there are just side effects of this data center. They produce the heat, and heat needs to be eliminated because it's have a negative impact on the devices that are running there. So they need to be exchanged, and someone needs to do the job, right? And someone needs to find the resources actually to produce these devices. And I have found on the internet actually the one article that I kind of not been successful in finding the resource of it, that says that actually from 40 to 80% virtual machines running in these data centers are idle, just waiting for a job, whatever is come or not. But just to be honest, although I don't have the initial source where it has been measured, we are the software developer, I may trust this percentage, yeah, in higher scale. Yeah. So when you put it into the different projection, yeah, the impact of the software industry, actually there was a research recently published in 2021 done by Tech Monitor. They trying to divide the actually emissions by the software itself, which is the scope 1+2, and scope 3, which is actually containing the whole value stream. It contains the customers and suppliers. They put it into the equation, and they have, I think, pretty large number of contributors to this. And as you see, if you measure the unique software, it doesn't look that bad, right? The Cisco is going pretty well. It's very small. Yeah. And Microsoft too. Sorry for Microsoft. Yeah. So, but if you measure the complete value stream, the Microsoft becomes to be second, one of the best producer of the carbon emission. And the Cisco is heading everyone is running a Citrix at home. So, the thing is that actually we really should start to consider to having energy as a part of the equation. What is the takeaway is, yeah, we should take a responsibility and accept all the challenges as a developers, because we just only have one planet to sustain. Yeah, it's the planet Earth. And I have formulated one hypothesis. It was very back to the Sun times. Well, Sun Microsoft time. So that there could be a platform that allows this kind of green development as efficient development of the application. Yeah. And yeah, I've just been elaborating on this idea. And recently I have created just a simple, very naive test. I took the calculation of the prime numbers, and I take the interval from 0 to 200 millions and repeat it 15 times. I haven't done it manually. Everything is automated. These numbers, yes. Everything is running itself. I just have to press the button, and it even sends me the data measured. So there are probes that measuring the electricity consumption. Yeah. And it's kind of produce such kind of table. And you see some platforms compared to platform we do like Java, I hope. So JVM are becoming more consumption per the task. Yeah. So let's put it into the different chart, how it looks like. One task, that means the calculation of a prime numbers from 0 to 200 millions, how much energy, how much kilowatt it consumes. Oh, well, Python is getting pretty noisy here. So let's move him back away. And as you can see here, I have split it across the processor and platform. And it seems like ARM-based platforms like Mac and Raspberry Pi are doing pretty well. Yeah, you cannot even spot it's here. Yeah, the small one. Yeah, so you see how much energy they consume. And compared to Intel, I need to say I don't have the last Intel. Yeah, so I don't know, maybe they already made some progress, but I had the Intel from 2021, the last one. So a few years are missing. But M2 was, I think, introduced by 2002 or something. So I wouldn't expect that big difference. But with this, let's keep in mind that the Java has been really effective. And let's go to our breaking milestone. It's a long support release and is a Java 21. And it brought a lot of great fixes and the new features. Actually, what it brought is it moved Java into the functional world. Yeah, not as it been before, but actually that it brought the features that developers actually expected in order to produce more maintainable code, more kind of immutable code, so that you see the record patterns and pattern matching for the switch. Yeah. And of course, some kind of nice fixes, which is the sequence collection. Don't forget them, because they actually unify the access to the first elements and the last and any n elements across the all collections, which I saw many times some internal implementations of fixing this issue. And that fix is here. Yeah, by the JEP 431. And pattern matching, I would little bit dig into this. Yes, it's here. And as you can see, maybe you've been missing this for a very long time and you just been forced to write some kind of obscure code actually to do the same thing on the few lines, although it has been in the header for a very long time. So it's here. And this actually is, for me personally, the real game changer, not only for maintainability of the code, but also testability and also understanding the code. Because these lines can be representing way more n lines of the code, like multiply probably. Let's see. So this was from Java 21. And as I said, we moved way more to the functional world. And recently published study from InfoQ in 2004 actually shows the trend of most of the company that have been contributing. You see, in the green majority, actually, the companies are trying to apply the functional paradigms to understand how the actor likes feature can be used to actually express their business scenarios, yeah, and how to maintain the code, and also how to exchange the data. If I take a look nowadays, a lot of things are about the IoT. So there is a lot of data mapping running around, and not only just IoT, just exchange the information across the different kind of node. And you see, the Java is really staying with the business requirement, because, oh, wait, in Java 22, there are coming more functional jobs that they support them. One of these are unnamed variable and patterns. And of course, for education, that's a nice that, and at 21, you were able to execute one class. And right now it was kind of annoying because you had to write everything into the one file. And right now it's just the students or newcomers can actually use the Java and execute the multiple files and the code, which kind of help them to learn how to separate the idea across the files. Yeah. And it's more as a previews, as a header said. So we are collaborating with the community. So one of the biggest requests was the super as the first line in the constructor. Yeah, which kind of was very cool, right? Until you have to make some condition. So you did it exactly after the super, but in that moment, actually all back long, the object has been already constructed and polluted your heap. Even when you created the whatever exception, yeah, it's even worse because you took everything into. So with this statement before the super, you can kind of ensure that this object is able to construct without actually taking a space from the heap. That's a great one. And then we have evolution of the string templates. Yes, as you say, structure concurrency, which is coming from the loop, which kind of should help to developers to express the concurrent parallel nature of the application they're developing. Yeah, with how the very deep knowledge of the executors and threads behind. And then we have also the scope values, which is kind of very nice to the virtual thread because they kind of allow to share values across these million threads instead of creating the thread local values, which again taking a space in the memory. So let's review a few of them. Unnamed variables and patterns. So imagine that you have very complex logic, right? And Java is very strong type safe and strong type language. So you need to ensure the type safety overall across all your transformation you do. So with this unnamed variables, you're getting a new head. So you don't have to actually force developers to declare everywhere the type. You see the underscore. So what it brings more is according to maintainability. So you don't have to maintain this part. So you don't have to ensure if someone change this field inside of object holder, yeah, which is obviously from there is a magic, right? So you don't care about the type, and it is eliminated later by the compiler. So you don't care simply. And this is exactly what functional word actually wants to have, right? And in order to maintain it also. So, and there are a nice example of the string templates that are coming into, and one more. Here is the multi-file source code program. So you can right now enjoy the Java on multiple kind of files written. And if you use just Java and main class, so it got executed. So, and this is all magic. Forget the compiler definition, forget the flags that you need to put in, just like this, and you have it. So one more JEP I would love to mention is the stream getters. So maybe some of you are using like a Kotlin or Scala. I mean, yeah, those languages are cool. Definitely, they have their place. So what I think the community has been missing since the Stream API has been introduced, there were a couple of intermediate operations that you can apply on the data actually that are in the stream. But what was missing actually to kind of work with them in more advanced manner to separate them under the certain condition, there was actually kind of hack to do is if you use the atomic references, they are effectively final, so you can actually contribute to the intermediate operation itself. Yeah, but it's not what it should be. So with this stream gatherer, you are able to create intermediate operation that you apply on the stream. For example, if you want to fork it based on the condition or just recreate the transformation. And when moreover, this feature is still inside of stream. Yeah. So that means it actually not as from the side effect using any external data. You can test it and you can maintain it. So I find this feature very great. It's the first preview, so you can give a feedback on the feature. And I think it's again functional way. So we are with the Java staying with the mainstream, and even more, we are contributing to the evolution. So conclusion, Java is evolving. Thanks for the 6 months cadency, pretty fast. They are coming the feature way faster than ever before. It enforced the maintainability, actually, and very simplify the code. So there is a reason to migrate. And as you may still remember, on the charts, you may see it also some differences on the performance or energy consumption. So, and yeah. Again, so right now, the whole business requirements are mostly about the mapping and functional kind of scenarios that we need to apply and create. So, and Java is actually moving that way. And data that I measured from my naive example, they say also that Java is a good platform to choose to stay green. So, thank you very much. And yeah, question and answer.
Yeah, maybe one from me. So while working on JSRs, is there anybody that says, oh, let's see what is the energy impact of it? Or it's just you make something take less memory, you make something faster, and then automatically you get more energy efficient code?
This is a good question. For that, I was a safe harbor because I'm not authorized to answer. You can ask Heather the same question. No, I mean, I think that there are companies that they are doing a research exactly on this, because if you have the millions of nodes on virtual machine running in a very big scale, 1% change in the energy may be calculated probably in millions. So, I mean, the companies like Amazon or Microsoft or Google or Oracle, they are, I think, looking into it. I don't know. Okay. Any other? Okay. Who was first?
Everyone, John.
Oh, you see, you have insights.
You haven't done yet as an industry decided whether that's something that should be done. Part of it missing it, and like we collaborate on one thing to create open JDK itself. You know, do we take a step forward and pay that in terms of power saving and stuff deliberately as a sort of European standard? Nobody knows yet. So it's all a very new space. But yeah, we definitely all want to go. Cool. Good deal.
Next one. Yes.
And yeah.
Okay, so it's very naive. So I get the plug and I get the plug. Actually, these gadgets are measured the consumption. So yes, and you can get the probe and they actually calculate with very small time with how they impact. So I can just extract the data out of it.
Because I think that there are some you gotta start this information also from the CPU.
Okay, this is the other things, but actually from the perspective how much your system consume, it doesn't matter how much data. I don't care how much data I need to maintain in a memory, in this trail. Of course, if you are running the big application and you need to allocate a big heap of memory, right? So you need to maintain this. So it will cost some money. Yeah. So it makes sense to measure, but I didn't care in my naive example. Yeah. So that's it. It would be too much. Okay, thank you very much.